as we look for x here, one thing to note in particular is that the x is only just this part of that. It is only the part that is basically the side of the triangle. And so if we're going to try to figure out what x is, even though we got this whole circle involved and all that kind of stuff, really this is all you're dealing with. You're just dealing with a triangle with that one side length of 1, and then we're trying to find out what x is. All right, now in order to do this, we're going to approach it the same way we approached all the problems last week. I need to start by deciding if it's sine, cosine, or tangent by starting by figuring out what do we call the side lengths. So the side that's currently labeled as 1 unit long. What do we call that side? That is the hypotenuse, absolutely. And then we're trying to figure out what x is. What do we call x? X is the adjacent, yeah. And so, which one involves the hypotenuse and the adjacent? Cosine. So, we got cosine of 72 because it's always cosine of the angle, equals, and cosine equals adjacent over hypotenuse. So I put the adjacent on top, that's the x, and the hypotenuse on bottom, in this case, that's the 1. Now, this is a very particular situation. This is a particular case which actually is going to make our life a little bit easier. Because what does x over 1 equal? Well, anything over 1 is just itself. So x over 1 is just x. So this problem, because it was over 1, because our hypotenuse was 1, all we have to do to figure out what x is do the cosine of 72. Go ahead and do that calculation. You notice we didn't have to worry about cross multiplying because it was much easier to say that x over 1 just equals x than try to write the cosine over 1 and cross multiply a bunch of times by 1 and still end up in the same place. And when you do this cosine of 72, you should be getting an answer of about 0.31. I just rounded to 2 decimals here. All right, now, remember where we started this problem from. Yes, we're just looking at a triangle right now that looks just like what we were doing last week. But remember that started with a circle. This is actually the way that we're going to be doing our work going forward, is it's all going to be based off of these circles. And so our triangles now are going to get built throughout this entire circle. They'll be going sometimes up and to the left, sometimes down to the right, down the left, whatever. And so building on the circle, you know, we just did find x. While we're here, let's go ahead and find y. So write down this problem, do the work for it, figure out what that answer is. So in this case, I'm looking to figure out what y is. Once again, I still have that 1 is where it was before. So 1 is still playing the exact same role. It's still hypotenuse. Y, however, is not the adjacent. Y is going to be the opposite. And so hypotenuse and opposite, that's got to be sine. Yep. So sine of 72 equals, and then sine is opposite over hypotenuse, so it's y over 1. Now remember why this is so much easier. This is so much easier because y over 1 is just y. So sine of 72 equals y, so if I want to know what y is, I do sine of 72, which gives me about 0.95, and there's my final answer. Now, these examples are all built on this one starting picture. Now notice some of the characteristics of this picture that I gave you. It was done very purposefully. In this picture, you'll notice that we have a circle and the radius. Remember, the radius is that segment that goes from the center of the circle to the edge of it. The radius is 1. And in fact, we're going to be building off of this and giving a little bit more information as well. Include both the definition and the picture. Make it a new picture. You can't use the old one because we're going to be adding some notes to the picture itself here, and that would just end up being too much stuff going on. And the first little detail we're going to add to the picture is how we measure the angle. the measure of the angle always goes from the same place so that we can be consistent here. We always start our angle measurement starting at the center and going right. Remember, the center is going to be at 0, 0 every time for a unit circle. So this one goes straight right, and then we always measure the angle going counterclockwise from there. So add that into your picture there, that we measure the angle from the right horizontal, and then we go counterclockwise from there. And that's going to be true no matter where that angle is. And just so you know, that angle will be going around even further. So, for instance, we might see an angle that looks like this. No, you don't have to redraw this one, but I want you to see that that same measurement keeps going around from that horizontal right side wherever it is. All right, now, adding on to that, I stripped away some of the extra stuff, but you can keep building this onto your picture there. So add now this triangle that gets drawn in with our picture. You notice to draw this triangle, we go straight down from the point on the circle where we're crossing. So right up there, you go straight down from there, and you intersect the horizontal at a right angle. The reason why we're drawing this triangle in is to help ourselves visualize what's going on with this picture and how we actually figure out what the information is. So in our warm-up, we actually saw an example of how this problem works. So for instance, this blue line here, this blue segment. We figured that out before. We were going to the right side instead of to the left. Remember, that gave us our x value. When we went up, we labeled that y. These are actually very purposefully chosen in that warm-up example because the x actually can represent the x-coordinate. And the y actually is the y-coordinate of the point where our radius hits the circle. Now you may recall we find those points by using sine and cosine. And so we have a general rule that we can apply here that cosine tells us our x-coordinate of the point, and sine will tell us the y-coordinate of the point. So add those labels to your picture there going forward. And then we can also formalize it with a little bit of text here. The coordinates of any point on the circle, unit circle in particular, can be found by doing cosine comma sine. So I want to build on this with another example. So here we have a unit circle. And the measure of this angle is 108 degrees, and we're going to be asked to find x and y. Write down the problem, and then we're going to see how to take that information and put it into something useful. All right, so let's figure out what this is really talking about. First of all, we're told that below is a unit circle. Now, we can be very tempted to just kind of overlook the fact there's actually information in that, because we might be tempted to just read it like it's just saying below is a circle. But it's very specifically saying that it is a unit circle. The unit circle is telling us something important. The unit circle, remember, tells us that this circle here is centered at 0, 0, and it's telling us that the radius is 1. And remember, the radius is any of the distance that's measured from the center to the circle, so I can measure the one along that side that I labeled. This side is also 1. All of those are going to be 1. It just happens that that's the one that's going to be the most useful at the moment. Because if I'm being asked to find x and y, what it's doing is it's saying basically find the x and y coordinates of that point on the circle. And we get to that point by going 108 degrees around from the horizontal. Now, how do we find those coordinates? This goes back to our notes, actually. You think about it like a right triangle. We think of this like a right triangle, and at first you might even actually draw it on, but pretty soon you'll find you don't have to draw it. But this is basically what we're envisioning. We get our x-coordinate by knowing how far over do I go from the origin. So notice here, that means I'm going left along that blue line. And to find the y-coordinate, that's how far we go up from the origin. So I can just see how high is that point to know what the y-coordinate is. Well, how do we find the x-coordinate again? Cosine, yeah. And how do we find the y-coordinate? It's sine. So really, this is what we're going to have to be doing. Now, in the future, you're going to be able to just kind of have this in your head. You're going to say, oh, okay, I need to find x and y. X is always cosine, y is always sine. But being able to help visualize it here on this is going to help along. Yeah, and so think about what to expect here. You'll notice that since cosine is going to the left, it's going to give us a negative number. And sine, since it's going upward, it's going to give us a positive. But whether we get positives or negatives will change depending on where we are around the circle. It's possible for cosine to be both positive and negative, and it's possible for sine to be both positive and negative. It all just depends on what that angle is. All right, so let's go ahead and actually figure it out. So first up, we're going to find out what x is. As we just discussed, x, remember, is the cosine of the angle. So I'm going to do cosine of 108 degrees. When I do that here, I'm hoping to get a negative because I can see where the angle is. So if I do it right, I'm expecting it. When we do it, yes, in fact, we do get a negative 0.31. So that's good. Notice I'm thinking ahead at the start. Should it be positive or negative? That way, if I make a mistake, I can catch it right away. All right, for sine, I'm going to be finding the y value with sine. Would I expect my sine here to be positive or negative? We're going up. So that's positive. We do that calculation, you end up getting about 0.95. Now, these numbers should seem slightly familiar to you. You notice that these are basically the same numbers that we started with. Just in this problem, they happen to be seen more as the coordinates of that point than just the sides of that triangle. But they mean the same thing as what you did in the warm-up today. The only difference between this answer and what we did at the start is that here our x-coordinate is negative because we're going to the left. That is because I happen to choose the exact same angle going to the left of that as I did going to the right in the warm-up problem. That's how that happened to work out. But just wanted to kind of show and see, yes, you can get the same ones, and there's going to be a certain amount of symmetry in these circles, and that's actually going to be something good to keep in mind going forward because you're going to start noticing some patterns here soon. All right, so we're now going to be taking a look at this diagram, which you now have in your hands. And at first, we're going to be focusing just on the upper right-hand corner of it. And we want to reason through some of the things that we know to be true about it. First of all, let's take a look at a few of the angles. So let's start with this angle right here. The horizontal angle going straight to the right. What's the angle measure there? Yep, many of you already know it. And if you're not sure what it is, let me show you why it is. Remember where we always start measuring our angles. We always start on the horizontal right. And then we're going counterclockwise from there. But notice this angle is on the horizontal right. That's why it is 0. So that angle is 0. We're then going to use that information to figure out what are the coordinates of that point on the circle. So in other words, what are the coordinates of this point? Now remember when it comes to the coordinates, 0, 0 is at the origin here. So this is 0, 0. Knowing that, and the fact that this is a unit circle, we can actually just kind of reason out what the coordinates of this point are. Because like going from 0, 0 here, going from the origin, how far am I going to the right to get to that point? It's a unit circle. So it's 1. Because notice, I just went from the center out to the edge. That's the radius. And the radius of a unit circle is 1. So if 0, 0 is where I started and I went 1 right, what are the coordinates of my point going to be? We go over 1 and we go up 0. So the coordinates of that point are going to be at 1, 0. Right, now, how can we know that for some of these other ones? Well, that's just what cosine of 0 and sine of 0 are. And we're going to be able to use that pattern to find all the other values as well. So like Cosine of 0, if you actually checked it, you would find that it is 1. And sine of 0, you would find that it is 0. Right, next up, another angle. What's the measure of the angle that's going straight up? It is 90. Yep. That's a quarter of the way around the circle. So we're at 90 degrees there. Now, if I know that 0 is down here and 90 is up here, I can use that information to figure out what that angle is. Yeah, that angle's got to be halfway between 0 and 90, which is 45. Now, from there, we got to figure out what this angle is. Now, this angle is actually a particular angle that comes up so often that we do name it. Now, you probably already have kind of an idea about what it would be. Yes, it is, in fact, going to be 30 degrees. Now, knowing that, we can actually know with some good certainty what the other angle is up here in the top right-hand corner. What's the measure of that angle? Yeah, very nice. It is 60. Now, I'm going to have you worry about filling in some more of the angles later. Just realize that the other angles will follow the same pattern. Explicitly speaking here, what I mean is, you notice we go 30 degrees to get to that first one, and then it's another 15 degrees, and 15 degrees, and then it's another 30 degrees. That pattern is going to hold all the way around. All right, but before we get to worrying about the rest of those angles and actually filling them in, let's get one more coordinate pair, one other point here. I want to know the x-coordinate of that point. And again, think about what that means. That means at this point on the circle, what is the x-coordinate? In other words, how far over do I have to go to get there? Well, what do I do to calculate that value? How do I find the x-coordinate of the point? It's in your notes. It is cosine. The cosine of 30 degrees, then, is about 0.87. And I'm just typing that in my calculator to find that out. Next up, I want to know the y-coordinate. Well, the y-coordinate, what do I do to find the y-coordinate? Sine, yeah. And what is the sine of 30 degrees? That's one actually you might know off the top of your head. Because that's the one we talked about as a great way to make sure your calculator is already in degree mode. You should be finding that it's at 0.5. All right, now once you've seen how to do those, we can start taking a look at the whole picture. And we can actually worry about filling in the whole picture as well. And so, your homework for tonight is going to be to fill in the entire rest of the picture. You're going to fill in every angle and the coordinates of every point that are labeled.